Click the bell icon to get latest videos from Ekeeda.
Hello friends, we have been discussing about various grammars to be written for programming language constructs. In this video, we are going to discuss about if construct, which is used in various programming languages. If else, nested if else, etc. First, we will write an ambiguous version of if else grammar, and then we will try to construct a grammar which is unambiguous in nature. Let us start with the first one, the ambiguous one. Let us try to understand the grammar which is written over here. It says that a statement is an if followed by an expression and a statement, which means that if the expression evaluates to be true, the statement would be executed, or else the statement is neglected. If it is not a simple if, it may be followed by an else. So the second statement says that a statement is an if followed by an expression, then a statement. If this expression is true, the statement is executed, or else it is not ignored. Instead, the second statement is executed. If the statement is not an if statement, it could be any other statement, such as an assignment statement or anything. Let us try to construct parse tree for a string using this grammar and try to prove that this particular grammar is ambiguous. The string that we are selecting for parsing is if expression 1, then if expression 2, then S1, else S2. There are two if, one over here, other over here. There is then, one over here, other over here. For this if then pair, there is one else. Using this statement, we never know that the else is associated with the first if pair or then, or the second if then pair. We will try to generate string. We will try to generate parse tree using the grammar and this particular string. Statement would be the root of the tree because it is the start symbol in our grammar. What is the yield of this parse tree? Expression 1, expression 2, then S1, else S2. In this tree you can see that the else statement is attached with the second if. Now let us try to draw one more parse tree in which the else would be attached with the first if and try to prove that this particular grammar is ambiguous. We have constructed one more parse tree for the same string. Now let us hear it. We have constructed one more parse tree for the same string. Let us try to yield this particular parse tree. If followed by expression E1 followed by then followed by if followed by expression E2 followed by then followed by statement S1, followed by else, followed by statement S2. Over here, you will see that the else is associated with the if in the starting. In the last parse tree, we saw that the else was associated with the second if. In the grammar that we wrote, the else is having an ambiguity with if. It might be connected with the first if, it might be connected with the second if. In that case, the compiler gets confused whether the associativity of else is with the first if or the second if. We have to remove this ambiguity and write a grammar which is unambiguous. In the new grammar that we have constructed, we have made two non-terminal. One is matched, the other is non-matched. Matched represents an if-else in which either we don't have an else or we have one else which is matching with the respective if. In unmatched, we are writing an open statement in which there is an else which is having unmatched if. Let us try to see the grammar. A statement is either a matched if statement or an unmatched if statement. Match could be if followed by an expression, followed by a then, followed by a matched statement, else again a match statement. That means a match is always complete. If it is not an if statement, it is some other statement. An unmatched is if followed by an expression, followed by a then statement. That means it is not having a matching expression. Or else an unmatched could be if followed by an expression, followed by a then, followed by a match expression, then followed by an open expression which is unmatched in the else clause. Now let us try to parse the string that we constructed earlier using the parse tree of this grammar. Over here, we have constructed the parse tree for the same string using the new grammar. Let us try to see the yield of this parse tree. It is saying a statement is an unmatched, which is if followed by an expression. Over here it is even, then, which is a statement having an if, an expression e2, then a matched statement s1, else a matched statement s2. You will see that this grammar is very peculiar in the sense that it will always associate the else with the nearest if which is possible. The nearest if for the else statement in this particular statement was the if which was second. If it was the first one, it would have connected the else statement with the first one. This fact you can even consider from the grammar. The else is connected with the unmatched over here itself. In that case, there is nothing which could come in between this else and the if statement in the unmatched. Similarly, in the match one, the if construct and the else construct are joined within the same production, which means that always the if and else which are associated would be connected using the nearest construction. This particular strategy will remove the ambiguity of the else which is dangling between the ifs. From the next video, we will be discussing a few more questions on programming constructs using the context-free grammars. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.